Lesson 1.7, our last lesson in chapter 1. Officially, it is modeling with functions. So we are trying to take different scenarios, write functions. We're using a lot of formulas basically today, and writing what we need into a formula type form. Example 1, we're going to look at writing the area of a circle in 3 different ways. So when it says here, write the area of a circle as a function of its blank. Okay? If we write the area of a circle as a function of something, when it's saying as a function of something, that's saying that is the variable we need in there. Okay, so all of these are going to be area, so area equals, but then it's, okay, what variable are we using within that function? The first one says write the area of a circle as a function of its radius. What do you know about area of a circle? Area is equal to pi r squared. Yes. That's the one you're supposed to have memorized. Yes, I said those words, memorized. You're supposed to know that. Area equals pi r squared. Right there, I just wrote the area formula as a function of r. Okay? There's nothing to do with this one. You know this one. That's just acknowledging that, okay, area of a formula is normally based on r, based on the radius. Now, we're going to take that formula and we need to tweak it. Because now in part B, we're being asked to write the area of the formula as a function of diameter. So I want an equivalent function here that's not based on the radius though, that's based on diameter. What do you know? Okay, so as we talk connection here, connection between diameter and radius. We know which way did you guys say it? Didn't you guys say something about radius and diameter when Emma knocked?
Diameter is half the circle. Diameter is the whole circle.
Radius is half the circle.
Diameter is the whole distance of the circle. Radius is half of it, yes? So there's 2 different ways we can write that. We could say that 2 times the radius is equal to the diameter. Or you guys just said that the radius is half the diameter, right? So we can think of that as d divided by 2, if you will. Okay, these are just right now ways to connect r and d. Because here's the deal. We're going to use, it was area equals pi times radius squared. Pi times radius squared. But I'm not supposed to be using r this go around. I'm supposed to be using d. What's the connection between r and d? Okay, r is half of d. So if this is pi times r squared, what can I put in place of r? D over 2, or 1/2 d. Now right there is an area function. This is area in terms of diameter because my variable is d. We can clean it up a little bit though. What is d over 2 quantity squared?
D squared 4.
D squared over 4? Yes? Because d times d is d squared. 2 times 2 is 4. How did I write this in my answers? I have this written as constants out front times the d squared. 4 is a constant in the denominator, yes, and pi is a constant. It's a number, isn't it? So I have this written as pi over 4 times d squared. That's not the only way. You could write pi d squared over 4. D squared pi over 4. Okay, I wrote pi over 4 times d squared. And that's just kind of more what we're used to, where you have the variable out, or the constants, the numbers out front, and then times the variable. Okay? What about C? What about circumference? What are you supposed to know about circumference?
It has area in it, right?
Isn't it?
No.
It's like the whole. It uses the diameter.
It could use the diameter. So circumference is your distance around the circle. There's a formula for it. One option.
4R, 2R.
Okay. This is an either or. Okay. When you learned years ago formula for circumference of a circle, or when you used it, I don't know if you ever really learned it because no one ever has it memorized in pre-calc, but technically this is something we should know. Circumference of a circle can be written as pi times the diameter or 2 pi r, because that would be pi times 2r, which is also pi times the diameter. Now, we're being asked to write this formula, or this formula, area, in terms of circumference. I would use this right here. We know area is pi times r squared, yes? Here's my connection between r and circumference. If we're thinking like we did last time, it was a equals pi times r squared. What is r when I solve this in terms of circumference? So if I take this right here and solve it for r, what are you going to do to get r by itself? Divide by
2 pi.
2 pi. We divide one side by 2 pi, we're dividing the other side by 2 pi. And so that means what is r equivalent to? C over 2 pi. I didn't say it was pretty. Okay. Now, take your area formula. Area equals what? Pi times radius squared. What's my radius here?
C over 2 pi.
Radius is equivalent to C over 2 pi. Are you following that?
Yeah. How are we going?
What did you say? How are we going to clean this up? Okay, well, I'm going to leave the pi out front for the moment. C over 2 pi quantity squared. So when you square the numerator, C, when you square it, is going to be C squared. Denominator, when you square 2 pi, four pi squared, right? Because when you take 2 and square it, you get 4. When you take pi and square it, you get pi squared. Okay? So, what do you know about this pi out here? What is pi as a fraction? Pi over 1. Why would I do that?
You can cancel.
Can I cancel a pi?
One singular.
I can cancel one singular pi. So we can cancel this pi on top with one of the pi's on bottom. So area equals C squared over 4 pi.
Just for the 4.
Okay. All of this was just taking one equation, though, and manipulating it. We took that area equation and we used what we knew about the connection between radius and diameter and the connection between radius and circumference. Okay? So just be able to look for those connections and replace them. Okay? Ready for the next one? Sure. We'll make sure there's no questions, I guess. Okay. Let's read the problem. This is a typical math problem, okay? Like, you'll see this. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-topped box. Write the volume of the box as a function of x. Okay? So, you got the visual or no? A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard. So here is my 8-inch by 15-inch piece of cardboard. Are we good? And then what are we doing?
Fold. This.
We'll fold the sides after we
Cut out.
We're going to cut out a square from each corner. So we're going to cut out a square there. We're going to cut out a square there. A square there and a square there. Yes?
Yes.
Pardon my squares that are not all the same. Each square has side length x. So each square is x by x. Yes? Put as many x's as there as you want. So you cut those corners out, they're gone. Then you can take the flaps and fold it up to make a box. Got it? Now, we're being asked to write the volume of the box as a function of x. Okay, dig deep. Volume of a box. Yes?
Yeah.
Volume of a box? What you learned years ago, yes? Length times width times height. Now, why can this not be my final answer? It's supposed to be in terms of x, and I have an L, W, and H. So we have to take the length, the width, and the height, and all put them into terms of x.
Yeah, like we did a few chapters ago. We just switched the x and the
Yeah.
y.
Okay. Length. Thoughts on the length of this box after I cut the corners out and fold up the flaps?
15 minus x. No, 2x. What? Because there's two squares on both sides.
And I didn't write all those in, but I probably should. That's a lot of x's there. Kind of getting messy. But, okay, the length from here to here is 15, yes? But what are we really just looking at? That piece right there, yes? So that is a length of 15 minus the 1x minus the other x, so 15 minus 2x. That is my length. Okay? So, you know where I'm going next. What about the width of the box? Yeah. From here to here was 8, but we're just looking at that piece right there, which was 8. Take away the two corners, so 8 minus 2x. Height of the box.
Wouldn't it be 8?
What?
Wouldn't it be 8?
No, not 8.
15?
No.
8 times 15.
No.
I'm
8
joking.
squared.
I don't know.
8 times 15 squared.
Okay. Visualize. I keep thinking. I always think to myself when I get to a section like this, I need to bring in I need to create a model for you guys to look at. Think about what's happening. We got this flat piece of cardboard, right? We're cutting out these corners, yes. So my 4 corners are gone. And then we cut out those corners, we've got these flaps here. Those flaps are going to fold up to make my box, yes?
Fold up. So it'd be 8 plus.
It'd be something with that.
The exit, the squares.
Yeah. X squared.
No.
Okay, so if I take up, I'm trying to figure out the best way to visualize this. So like right here, in the green, that's a flap that's still sitting there, yes?
Yes.
I'm going to take this flap and I'm going to fold it up.
So it'd be 15 minus 2x plus 8.
No, you guys are making this way too difficult.
Yeah.
If I take that flap and I just fold that flap up, that flap is the height of the box. That flap is just X.
Oh.
I think
No,
no, just told us that. How's the box gonna close?
It doesn't.
Open top box.
So it's
I don't
literally
like
just a
this.
flat piece of cardboard?
There's a flat piece of cardboard. It's like me taking a piece of paper, cutting out a corner, corner, and then folding up the flaps. No? It's like, well, that didn't work. Gotta cut all the way. So if I cut, there's two corners, cut out an X, right? So this is X, this is X. If I take this flap now and fold it up,
Oh, yeah.
there's one side of my box. Does that make sense?
Yeah.
Not the best box ever.
Shh. We're not judging the box, okay?
I thought that was a really good box. I mean,
Well, she's about
I
to
was
float it more.
visualizing,
Okay,
like,
wait,
the
it's actually
moving
gonna look
box.
like a box.
Yeah, well,
Your jaw is way
Yeah.
I don't know, these squares aren't very equal,
I was
so.
visualizing like an Amazon box. That's why I was
Like with a lid,
Yes.
no, that's like
no lids.
the things they give you a pet coat.
I mean, what are you putting in that box?
Okay, so here is my very sad open top box.
So it's really just a tray.
A cake pan.
More of a,
Hey, they did not mislead. They said open top box.
It is
They should have related it to like the cake pan.
It's a shoe box without the lid.
It's a diorama.
a what?
Diarrhea.
Okay, now,
Diarrhea.
with this in mind, folks, have we rewritten the volume formula?
Yep.
We took volume, instead of it being in terms of L, W, and H, it's now all X's, yes?
Leave it be. Don't even touch
Please don't.
Guess what?
Simplify.
I left it be in my answer key.
it. Yes.
I left it as this right here. Now, I'm kind of surprised because I actually thought in previous years I had multiplied it out, but
Oh no.
Yes, you did.
now, what could you do if you had to? We could take these two,
Distribute.
we could take these two parentheses and FOIL, and then take the X and
Throw it in.
distribute it in, yes?
Yes, there.
Or just throw it in, whatever, but distribute would be the better
Sometimes
mathematical
I
word.
like distribute, and then I think I have to factor, and then I end up with the original.
The original problem in the loop.
Wait.
Okay, let's talk about Mark.
Oh,
I don't want to.
I don't even know about that.
Okay, Mark received an 8.5% salary increase.
ooh.
His salary after the raise was $36,890. What was his salary before the raise?
Oh no.
You multiply by 0.85.
No.
Just kidding, times 8.5.
No.
Alright then. I'm done.
You subtract 8.5.
No. You'd have to convert 8.5 into a decimal, right?
We do need to do that at some point.
And then can't you multiply what he had by decimal?
And then subtract it from the original amount.
Just take 8.5% of
Some variation of that. I'm not 100%. I didn't totally catch it,
It's like
but
when you go to the store and they tell you you have 40% off, so you multiply that number by 0.4 and then subtract that amount from the original number.
except I don't know the original number.
That's what we're
Just-
But that's what's fine.
No,
Okay.
subtract-
But here, we're going to use this idea, okay? Now, first of all, what is 8.5% as a decimal?
0.08.
That's where Stetson I had to decline because you just said 0.85.
Oh,
Okay?
I was testing you.
Okay. Well. Now, So, okay, let's use the idea of, Katie says when she goes to the store, something's 40% off. She's going to take that item price and multiply by 40%. Now, what is the price of the item? That's what I don't know here, because in this case, what was his salary?
X.
We're going to use X. So we're going to take 0.85 times X, right? Now, the catch here is that whatever this 0.85 of X, that's 8.5% times his original salary. We know after the raise, he has $36,890. So what is this 8.5% added on to? If it's an 8.5% raise, his original salary. So I'm going to have us think about this as original salary plus 8.5%, and altogether that's going to equal the $36,890. And if you don't like the 8.5%, think about, throw in your 40% at the store, right? So this is the idea that 8.5% raise added on to the original salary is going to equal $36,890. What is X plus 0.085X?
32. What?
Absolutely.
Oh, 1.085 X.
Just X.
Oh, there.
It is rough in here today.
Why are we doing all this extra work?
It's not extra work.
I don't have an answer yet, so I don't call it extra work.
Why wouldn't we
Wait,
just?
so the X is the same variable? So
Yes.
what's the first one supposed to be?
So this is his original salary plus his raise. His raise is 8.5% of his original salary. Okay, so that's right here we have the original plus the raise. And the raise is not just he gets 8.5%. It's 8.5% of the original. So the idea of 1.085, his salary is now going to be 1.085 of his original salary. How do we solve this? Divide. The calculator is doing the division. What's the calculator giving us?
I did not pick mine. Daycare. Yeah,
Oh.
from daycare.
Take it.
Okay. Your calculator would give you 34,000.
Exactly?
Yes.
That is so nice.
Okay. So, what is that 34,000?
His
Original
salary.
Original salary. So if you take 34,000 and you multiply it by 0.085
You should get that.
and you add it back on to 34,000, you're going to get 36,890.
Wow.
Okay. Now, what about the cost of an item after a 45% decrease?
Of an item? Just any item?
An item, which means what am I going to use for the cost of an item? X.
Wouldn't it be 1x minus 0.45x equals x
Settle down,
again?
Seth.
Okay, now here's the deal. We don't have an equation here. But think about it. It's the original price minus 45% of the price. What is 1 minus 0.45?
Oh gosh. Negative 1.45.
It is not negative. It is
What is 100 minus 45?
0.55. My bad.
Now,
I'm sorry.
there's a good lesson to learn.
We're fully.
Let's take Katie's 40% off. She takes two steps. She does 40% of an item and then subtracts it from the original price. How about just doing 60% of the original cost?
That's
Genius.
Save yourself a step.
That's so genius.
Okay,
Give myself
you can start working on the homework if you want, but we've got 2 problems to finish Monday, and then you'll have some work time. And maybe I'll go ahead and hand out the review worksheet as well.
You don't have to do that.
So, we'll see.
Emma, my freaking